Hi there, Samina. This is a quick summary of all the different concepts it seems your teacher is asking about triangles. Some of this material will be a review, I suspect. It'll take us about a half an hour to get through it, but I think you'll find it very helpful. Or at least by God's mercy you will. The first is simply how we classify triangles, names of triangles. The first way we classify triangles is by their angles. Okay, so in the first triangle, it's called acute. If all three angles, let's say this was 60, and let's say this was 50, and this was 70. If all three angles are less than 90 degrees, then it's an acute triangle. If a triangle has only one angle that's 90, then it's a right triangle. If a triangle has an obtuse angle, which is an angle greater than 90, a single angle, then it's an obtuse triangle. And if a triangle has all three angles congruent, which those are congruent symbols, or you would see this, all of them automatically would be 60 degrees, that's called equiangular. So acute, right, obtuse, equiangular. That's classifying triangles by angles. All right, scaling is none of the sides are equal. Notice the hatch marks don't match, 1, 2, or 3. Or let's say this side length was 7, this was 8, this was 9 inches. Then that would be called scaling. If there are two equal sides, that's called isosceles. All three sides equal, that's called equilateral. So classifying triangles by their sides is scaling, isosceles, and equilateral. Now here's a very simple but important concept for all triangles. If you take the three angles of a triangle, let's just sweep them, angle 1, and you put them back to back like pizza slices. Angle 1. Just trace these as I trace them. See how I'm doing that? Look, the little arrows. Trace. Trace angle 2. Trace angle 2 here. Trace angle 3. Trace angle 3 here. You see that these three angles, the three corners of a triangle, add up to 180 degrees. And that's true of all flat triangles. 180 degrees. The three angles of a triangle will always add up to 180 degrees, a flat triangle. This is called plane geometry. Planar would be the adjective, geometry. Now there's another concept involving angles of a triangle. First off, you need to extend the dotted lines. Just trace along the dotted lines and extend. Trace along the dotted lines, extend. These three angles, angle 6, angle 7, and angle 8, those are called exterior angles. Those are called exterior angles. And what this principle says is if angle 6 is exterior, the two angles that are far away but still inside the triangle, that'd be angles 1 and 2, add up to angle 6. So angles 1 and 2, this remote interior angles, what angle add up to, the measure, sorry, my handwriting's a little bad this morning, I apologize, the measure of angle 6. 2 and 3 would add up to angle 7, the measure of angle 7. And 3 and 1 would add up to the measure of angle 8. So once again, what this is saying is each exterior angle is equal to the sum of the remote interior angles. Remote means far away, interior angles. Now I'm going to talk about something that's very simple but very important. This is called the triangle inequality theorem. The triangle inequality theorem. It's just a really simple idea. The shortest side of a triangle is opposite the small angle of a triangle. So do you see that's the small angle of these three angles? The small angle of the triangle. So the shortest side is across the smallest angle. And then you have this. The medium side is across the middle angle. This is the middle angle here. The medium length side is opposite of the middle angle. And then the longest side of a triangle is always opposite or across from the large angle of a triangle. So the shortest side is across the smallest angle, the medium side is across the middle angle, the longest side is across the largest angle. So the length of the sides influence the angles. Shortest side, smallest angle. Medium side, middle angle. Longest side, largest angle. Which brings us to our next very important concept. What happens when triangle side lengths are of equal length? Here, this triangle is scaling, and we have a short, a medium, and a long. It's a scaling triangle, which means no equal sides. But I just said that it's possible to have equal sides. So what happens when you have equal sides? When you have two sides of a triangle congruent, then you have two angles congruent. I imagine visualizing like this. If you put your arms up like a triangle like this, I'm going to close it up, I'm going to make a triangle. If you have two equal length sides, two congruent sides, then the angles across from the sides are also congruent. See the blue there? I imagine this across like this, opposite. So if you put your arms up like this and your fingers together, you imagine it like this, is if you have two arms that are equal, then your elbow angles are equal. If you have two arms that are equal, then your elbows are equal. I'm just giving kind of a slang analogy here. So in this diagram, let's first mark our equal sides. If these two sides are equal, just trace them. The hatch marks kind of point, just kind of draw this into the corner. that if those two sides are equal, these two angles must be equal. If you rotate the triangle, if these two sides are equal, kind of follow those hatch marks down, then these two angles are equal. Two equal sides, two equal angles. Let me give you one illustration that's going to summarize everything you just learned. You ready? Here we go. Do you see those hatch marks? Let's trace these two sides. These two sides are equal. So kind of the hatch marks point to the corners, or the elbows, if you will. If those are equal, then it's these two angles that must be congruent. And now we're going to find every other angle that's possible here. First, we're going to go like this. We're going to see these two dots. Samina, see those two dots? Put those dots on your paper. Now I'd like you to connect those dots like a rainbow. That's 180 degrees. Now I'd like you to sweep the 114 and now I'd like you to sweep this angle right here. And I want you to find the measure of that blue angle. I'm going to give you about 20 seconds to figure that out on your own. Okay, what you should have noticed, you should have been doing, it's 180 minus 114. And we got 56 degrees. Now remember, I think in one of my previous talks, we talked about vertical angles. Vertical angles. Simply trace these two straight lines for me, Samina. See the orange? I'm going to make it a little bit bigger. Trace these two straight lines for me again. The angles across from each other, they're called vertical angles. They kind of look like a bow tie on or a cat whiskers. If this is 56 over here, this is also 56 degrees. And if this is 114, this is also 114 degrees. Now, see those hatch marks? Because of those hatch marks, if this is 56, this is 56 degrees. Finally, you just learned that, or relearned that triangles add up to 180. So we can do this, 56 plus 56 is 112. And we're going to go ahead and subtract. And that means this angle here is going to be 68 degrees. So just to recap what you learned. 1, triangles add up to 180. Triangles add up to 180. 2, if you have two equal sides, you have two equal angles. Two equal sides, two equal angles. Okay. 3, angles that make a rainbow add up to 180, and angles directly across from each other are congruent. All of these talk about relationship within a single triangle. Now we're going to talk about relationships between two triangles. We kind of went a little bit over this last lesson, but I didn't go into detail. First, we're going to talk about triangle motion. Translation is a slide Reflection is a flip like a mirror. Go ahead and do that. Rotation is a turn. Let me just recap this. What's important to understand, if I take a triangle and I translate it, which means just to slide it right, left, up, down, or I take a triangle and I flip it across a reflection line, or I take a triangle and I rotate it on a single point. You can kind of see how this got turned from here to there. What's important to understand is that all three of these motions create congruent triangles. The beginning and ending triangle are congruent because you're just moving the same triangle around. You're not changing the size. And when triangles are congruent, all their corresponding parts are congruent. I'll give you an example. You can see here, if you looked carefully between this triangle, W, X, Y, if you could trace exactly that, what I just traced, that would be great. Let's do it again. W, X, Y. And then you have this second triangle, E, Y, C. If you look very carefully, you can see that the green triangle rotated into the blue triangle. If you take the green triangle and you rotate like this, then you will get the blue triangle. So right off the bat, we know that these triangles are congruent. They're just rotated. And if the triangles are congruent, all the corresponding parts are congruent. For example, angle W is congruent to angle E. Angle X is congruent to, see the double sweeps, to angle Y on that side. And angle Y with the triple mark on the left is congruent to angle C with the triple mark on the right. Side WX, just trace it. Trace YE is going to be the same as YE. Side XY is going to be the same length as YC. And side WY is the same length as E to C. This concept of the whole being equal and parts being equal, it has a fancy acronym, CPC-TC. Corresponding parts of congruent triangles are congruent. What this basically says, if the whole is equal, the parts are equal. It's like saying, if I have two hands that are congruent, then all the individual fingers are congruent. The motion of left to right was rotation. Now, why it's important to understand this is because we're going to talk about congruent triangles. And there are 4 shortcuts to congruency. Now, keep in mind, when we say triangles are congruent, there's a total of 6 pairs of things congruent. 6 pairs. Let's just spell them out. In this situation, angle W was congruent to angle E. Angle X on the left is congruent to angle, this double sweep angle on the right. And angle Y on the left is congruent to the also triple angle, angle C on the right. Then we had 3 sides which were equal. WX was congruent to EY. And then if you go X to Y, that's going to be congruent C to Y this way. And the last one, W to Y, has to be congruent E to Y. So when triangles are congruent, there's a total of 6 pairs of things congruent. 6 pairs. Always. Now what the next 2 pages say is this. It's a shortcut. These shortcuts say if only 3 pairs of things are congruent, then all 6 must be congruent. So the 3 shortcuts to triangles having all 6 pairs congruent, if they have a minimal of these 3, a minimal, then automatically the other 3 things are congruent. So first I'm going to read them. Side, side, side congruency says if all corresponding sides are congruent, then the triangles are congruent. If you have a pair of sides, when I mark sides congruent, I like to trace them, and for each pair, I put 1 S. I have a pair of sides congruent. And then if another pair of sides were congruent, at 1 S for each pair. And I have another pair of sides congruent, 1 S for each pair. Notice I'm staying on one triangle. This is called side, side, side triangle congruency. Side, side, side triangle congruency. Here's another example right here. Right here we have a pair of sides congruent. This hatch mark says we have another pair of sides congruent. And then there's what I call like hidden congruencies. Do you see how this side is shared by 2 triangles? It's the exact same side. So we say it's congruent to itself. That's called the reflexive property. And if we have that side's congruent to itself. So here, this triangle here and this triangle here is demonstrating side, side, side congruency. Another one is this. It's called side angle side congruency. If a pair of sides are congruent, a squeeze angle. I'm going to put quotes around that. That's kind of a slang term. And then you have another pair of congruent sides, then the triangles are equal. If sides are congruent, a squeeze angle, and another pair of sides are congruent, then the triangles are congruent. Here's an example. Let's say I have a pair of congruent sides. Then I have a pair of congruent angles. 1A for angles for each pair. Then I have another pair of congruent sides. This is called side angle side. And what I mean by a squeeze angle, notice this angle is squeezed between 2 distinct congruent sides. So this spells out the shortcut side, angle, side, congruency. Here's another demonstration. You can see here, go ahead and trace those with the hatch marks. We have a pair of congruent sides. Notice we have a pair of congruent angles. And you're like, there's nothing else congruent. Oh, yes, there is. Remember that side that's shared by 2 triangles? that yellow side is shared by two triangles. It's also congruent to itself, a side. Look very carefully. A pair of sides, then an angle, then a distinct pair of sides. This spells side, angle, side. Now the next two shortcuts are easily mixed up, so I have a little memory technique I use. This one is called angle, side, angle. It says if you have a pair of congruent angles, then a pair of a squeezed side, and then another pair of congruent angles, then the triangles are congruent. It looks like this. If I have any pair of angles, and then I have another pair of angles, again, I'm using 1A for each pair, and then I have a side that's squeezed between these two distinct angles, squeezed between, that is called angle, side, angle. And another way I imagine this is I imagine the side being like a hamburger patty and the hands being two angles. So you can see the two angles squeeze the hamburger patty. That is angle, side, angle. So here's another example. You can see in this diagram that we have a pair of angles, and then we have a side, and then we have another hidden pair of angles called vertical angles, the angles that are directly across from each other like cat whiskers. And you can see that you have a pair of angles and a side squeezed between. This spells angle, side, angle. Now this last one says if you have a pair of congruent angles, then another pair of congruent angles, and then a congruent of what I call tail sides, then the triangles are congruent. This spells angle, angle, side, or side, angle, angle. Let me show you what I mean. If you have a pair of congruent angles, then another pair of congruent angles, one pair of congruent angles, then another one, and then a side. Notice the side is not squeezed between two separate angles, just touching one. This spells either side, angle, angle, or you can say angle, angle, side, same thing. And that means the triangles are congruent. The way I envision this is you have an angle like a dog snout, an angle dog rear, and then a tail here. Okay? Angle, angle, side. Now, two sides and an angle like that doesn't work. So here's an example of angle, angle, side. You see you have a pair of angles. And then notice you have a pair of undercover congruent angles called vertical angles. And then you have a pair of sides. Now notice that side is only touching one of the two pairs of angles, not both. So this spells side, angle, angle, or angle, angle, side. So your shortcuts are this: side, 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 angle, side, angle, side, angle, or angle, angle, side. Now the question arises, where do you get congruent things to begin with? Where do you get things to be congruent? And there's 3 ways to get them. And it is this. If the information is given, it's simply on the diagram, or you're told it's congruent. So you get congruent things by given information. You also get congruent things that are implied either by the given. You also get, I call them freebies. Put a quote around this. This is not a technical term. These are things that are congruent even if not marked. An example of a freebie would be vertical angles. And then it's important you talk through why are the triangles congruent. Talk it through. It spells the acronym GIFT. Given, implied, freebies, talk through. Let me give you an example of each. A given, if it's marked on the diagram or it's given to you in written information, that's given. So in this case, I would have a pair of sides and another pair of sides. Now, implied, if you're given a statement like this, AC, trace it, bisects BAD, the angle BAD. Angle BAD is being bisected, so you sweep it. Then that implies that these 2 angles are congruent. You have a pair of congruent angles. So it's implied by that word that AC bisecting the angle BAD that these 2 angles are congruent. It's implied. Then you have what I call the freebies. These are things that are congruent even if it's not marked. And there's 3 of them. The first one is what's called a reflexive side. If a side is shared by 2 triangles exactly, that would make it a reflexive side. It's also congruent, so you'd hatch mark it, put an S. In these overlapping triangles, look very carefully. Trace the larger triangle. Now trace the smaller triangle. Do you notice that the larger triangle and the smaller triangle both share angle H? We would call angle H a reflexive angle. It's congruent to itself because it's being shared by 2 triangles. And last but not least are the vertical angles, the angles made by 2 straight lines directly across from each other. Now with all these notes, Samina, now we're going to do the problems you asked about. Okay, ready? So in this problem, let's just make a couple observations. In this diagram, notice we have 2 equal sides. If we have 2 equal sides, we're going to hatch mark them. Then you kind of follow the hatch marks into the corner. If you have 2 equal sides, it implies you have 2 congruent angles. So in this diagram, as I see it, angle A is going to be congruent to angle C. Now the question itself, I don't quite understand the question itself. Let me read it and see what's going on here. The question itself says, what are these parts of an isosceles triangle? Is that applied? Called. Okay, in here, let me name everything for you. The two equal sides are called the legs. The one corner that's squeezed between the two equal sides, that's called a vertex. The two angles that are congruent, such as A and C, those are called base angles. So once again, the two equal sides are called legs. The point that's squeezed between the two equal sides, that's called a vertex. And the two equal angles of an isosceles triangle are called base angles. Now keep in mind, base doesn't mean bottom. I could have easily turned the triangle like this. I'm just going to turn it sideways so you can see it here. Let's have B, A, B, C like this. If I have two equal sides, these would be called the legs. B would still be the vertex. And A and C would still be what's considered the base angles. Okay, taking a look at this triangle. Remember this simple concept. Triangles, two important concepts here. One is the fact that triangles add up to 180. That's what's important here. Two, when you have two equal sides, you have two equal angles. So let's look at what we have here. Notice very carefully. We have two equal sides. If we have two equal sides, you kind of follow it into the corner. That means these two angles are congruent. This angle 40 and x plus 5. So that means if this is 40 degrees, over here is 40 degrees. That means the equation x plus 5 has to equal 40 degrees. And in this case, the variable x is going to equal 35. We also remember that triangles add up to 180 degrees. So I can add 40 plus 40. And I get 180. Excuse me, 80. Take it away from 180, which triangles always add up to. And of course you get 100. That means that this angle up here has to be 100 degrees. And how did we get that? Just the fact that triangles add up to 180, two equal sides, two equal angles. Number 3. Look very carefully. You have now, what I'm seeing is 3 equal sides. If you have 3 equal sides, you have 3 equal angles. So first thing I notice, if this side is 12, this must also be 12. So x plus 4 equals 12. Minus 4 both sides, and x equals 8. Taking a look here, if all 3 angles are equal, I'm going to go 180 divided by 3. And that means that this is 60 degrees, this is 60 degrees, this is 60 degrees. So I have y minus 10 equals 60. And we see here in this case that y is going to equal 70. Okay, angle 4 asks this question. Are the triangles congruent? If so, what's the rule and which triangle is congruent to which triangle? Now, when they say what's the rule, it's going to be one of these four. Okay, one of these four. Side, side, side. Side, angle, side. Angle, side, angle. And angle, angle, side. It's one of those. Let's see what we have here. Let's trace. In this case, BC is congruent to EF. Notice the hatch marks. Whenever I have a pair of sides, I put one S for each pair. AB is congruent to FD. It's another pair of sides. And then, of course, this extra symbol means these are also congruent. So we can see right now the shortcut being demonstrated. One, are they congruent? The answer is, of course, yes. Why are they congruent? Side, side, side. Now watch this last rule very carefully. A, B, C. Watch the order. Watch the order very carefully. A to B goes across the double hatch mark. B to C across the one hatch mark. Then we go back and we have circle. So it's, the order is double hatch mark, single hatch mark, circle. Okay, that's the order. You have to be very careful that you align these. So angle A is going to align with angle D. Angle B, which is between the double and the single, is going to align with angle F. And angle C, which is between the one hatch and the circle, aligns with angle E. So you have to follow that order very carefully. So A, B, C is congruent to triangle D, F, E. All right, let's take a look at this one. Now, it first asks, are these triangles congruent? Now, remember I've introduced 4 rules so far. Side, side, side. Side, angle, side. Angle, side, angle. And angle, angle, side. This one's a little tricky because this is the one exception. Take a look at what we have. We have a pair of sides. We have a nut. Okay, let's take a close look at these hatch marks. Samina, watch very carefully. I'm not sure if you redrew the diagram incorrectly or whether this is the exact diagram, because notice there's a mismatch. There's one hatch mark here and 2 hatch marks here. And if that's the case, if that's the exact diagram, these triangles don't match. And if that's the case, this would be a not congruent. Okay, now, I'm not sure if that's the case. Now, if perhaps your diagram looked like this, I don't know what the original diagram looks like. If this was single and double here, this would be a pair of sides, another pair of sides, and then an angle. Now, this looks like it spells side-side angle, which it kind of does. And remember, I told you originally that doesn't work. There is only one exception to that. If this angle is a right angle, we don't call this side-side angle. We call this hypoleg. This only works for right triangles only. So hypoleg would make these congruent. But I'm not sure if your original diagram had 2 hatch marks here. If your original diagram really was 1 hatch mark here and double hatch mark there, then it's not congruent. Okay, taking a look here, it asks, explain if the triangles are congruent, use the rules. Let's see what we have here. Watch very carefully. Trace these two sides, hatch mark, put an S. We have a pair of sides. Trace these two sides, go over those double hatch marks, we have another S. Now careful, there's a freebie here, something that's equal that's not marked, and that's A to C. Put another S. So this is an example of side, side, side. Now the only thing you have to be very careful to align are the vertexes. Notice if we go like this, C, B, A. Watch what we do. C, B, A. We are going from short to long and back. So we have to follow that exact order, short to long and back. And that's going to be triangle ADC. So taking a look at example 7, it says, are these triangles congruent? And it says, which rule is being used? Once again, that's either side, 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 angle, angle, or angle, angle, side. Let's see what we have here. We have a pair of sides, one pair, one S for each pair. Notice then we have a pair. There seems to be an angle here, but there's no angle marked there. Do you see how that's missing? And then there's another pair of sides. So on the left, we have side, angle, side, but on the right, we only have side, side. There doesn't seem to be an angle squeezed between. Okay, unless that's a mistake. If there was an angle here, that would be side, angle, side, and that would be the rule. But if there isn't an angle there, we would say not congruent. They are not congruent. Now, if it's a mistake and there should be an angle there, Samina, then the rule would be side, angle, side, and CBA, notice that's nothing there towards the angle, would be FDE. If there is an angle in your textbook, and that's miscopied. But if that's not miscopied, and that's all you have is side, angle, side on the left and two sides on the right, then that's not a match. None of them match. Let's take a look here. Watch very carefully. One hatch mark, we have a pair of angles. Notice here, two hatch marks, we have another pair of angles. Now, there is a mismatch here. We have a side that's not squeezed between the angles, and then this side is squeezed between the angles. Let me get a little closer here. In this diagram, this side here is not squeezed between the angles, and this one is squeezed between the angles. So on the left, it spells angle, angle, side. On the right, it spells angle, side, angle. So there's a mismatch here. Therefore, they are not congruent. This last one, we have a pair of sides. We have another pair of sides. And then we have a pair of vertical angles that are always congruent, even if they're not marked. So this spells side, angle, side. On the right is also side, angle, side. So side, angle, side would be the rule. Let me just erase everything so it's easy to see the matchup. So the matchup is this, B, C, A. Watch, B, C, A. We're going past single, middle, double. Past single, middle, double. That's the order. So we have to go past single, middle, double here. Therefore, it's going to be triangle D, C, and E. All right, I hope you found this helpful, Samina. I know this was a lot of information, but I'm sure you're going to do great.